Hello viewers, in this video I will discuss on the concept or on the first law of thermodynamics. So let us see what are the terms involved in first law of thermodynamics. See, first we have delta Q. What is delta Q? Heat supplied to the system from the surroundings. Okay, next we have delta W. Work done by the system to the surroundings. Next we have delta U. Change in internal energy of the system. Okay, so now what is the equation? So the equation says that delta Q, the heat supplied, will be converted into delta U plus delta W. This is the equation of the first law of thermodynamics. This is the equation of first law of thermodynamics. Okay, according to the law of conservation of energy. So based on the law of conservation of energy. So the total heat supplied, it is converted into the change in energy of the system and also work done by the system to the environment. Okay, so this is a statement given by the first law of thermodynamics. See, so now let us consider this as a cylinder. Okay, just imagine this as a cylinder. It is enclosed by a piston. So consider this as a piston. So now we have system inside. This gap is filled by some air or gas molecules. Let us consider this as a system. Okay, now let us see what happens when heat is supplied. So now see, so this is the process when externally we see that from the surroundings heat is supplied to the system. Okay, so it will burn my hand. So when external heat is given to the system, what happens? What happens to the system? You see that there is a change in internal energy of the system, and also see that the molecules of the gas vibrate vigorously, and there is a change in kinetic energy of the system, which in turn expands. The gas molecules expand. So when the gas molecules expands, what happens? This piston moves upwards. This piston moves. This piston, see that it moves upwards like this. It moves upwards. So this movement of the piston, what? It is the work done to the environment. This piston will be connected to some place to the environment. So work is done to the system or to the surroundings by the system. Okay. So this is the way of changing the given heat to change internal energy and the work done. So this is about first law of thermodynamics. Okay. So how we change the state from one state to another? So let us take a state as P1 V1 and we want to change to another state as P2 and V2. This could be done by either keeping pressure as constant and changing the volume, or keeping volume as constant and changing the pressure. So that is the way of changing from one state to another state. Okay. So now when delta U becomes 0, what happens? When there is no change in internal energy, see that the total heat supplied will be converted into total work. Total heat will be get converted into total work done. Okay, this is a statement. This is also another point to be note down. Okay, so now what is this delta W? Okay, let us take like this. So as we have seen earlier, this is the piston. Okay, and we know that we have gas molecules here. So we have gas molecules here and we have piston in this position. So what happens when heat is given? So what happens when heat is given? So normally we see that the position of the piston changes now. So we see there is the position of the piston changes as the volume of the molecules get increased. We see that there is a change in volume, so that the piston moves away from this position to this position. This is the change of the piston position. So here what happens? There is a change in the position of the piston due to the external heat. Okay. So normally what is work done in case of mechanics? It is force into displacement. Now in case of thermodynamics, this work done is written as, in terms of force it is pressure, and in terms of the displacement it is given as change in volume. Okay, so this delta W is written as pressure into change in volume. So this equation can be written as delta Q is equal to delta U plus P into delta V. This is also another equation. Okay, so this is about first law of thermodynamics. So from this we can find what happens to the given amount of heat. It will be converted into internal energy and work done. Okay, so these equations can be used to find any unknowns. Okay, thank you. Viewers, in this video, let's have a small demonstration of the first law of thermodynamics. So what is first law? So when you give some amount of heat, that heat is converted into change of internal energy and some work is done to the environment. Okay, so now first we will give the heat supplied. So heat is supplied. So now I am going to keep a bowl full of water above the surface of the heat. Now see that this water is not a system. So when we heat this water for some time, we see that vapor comes out from the water. So that vapor, after some time we see that it expands. There is a change of volume of the vapor, which in turn, if I keep a lid above the surface, we see that it moves the lid. It is similar to the movement of a steam engine. In steam engine, this is the same principle followed. Okay, so let's see what happens when vapor forms. So here we can see that the water gets evaporated and the vapor pushes the lid above, like what the same happens in case of a steam engine. Okay, so here, so this is, you can see that vapor forms and the vapor expands and it pushes the lid above. So this is the same principle will take place in case of steam engine. So in steam engine also water gets evaporated, in which the vapor expands and it moves the piston above, in which work is done to the surroundings. Okay, so this is based on the first law of thermodynamics. Okay.